Good afternoon, this is Jonathan Harsh. I'm making this video for FTT 122 for week 6 assignment. The date is September 13, 25. So trajectory and sights. For that first one, I'll go ahead and use my fingers for that. So if you muzzle up, you're going to arc the round, drop it in on your target, hopefully on a target that's farther away. It can pass through, they call it 2 times that it can pass through if you're shooting at an upward angle, or it will arc through, and as it's dropping back down, it'll pass back through your sights again. So that's trajectory and sights. The gyroscopic drift or spin. So the gyroscopic comes from just the rotation of the round. If it's spinning left, it's going to tend left. If you have right spin on it, it's going to spin right. Drag is all the air force that's coming against the round on all exposed surfaces as it flies through the air, creating a slowing effect on the bullet as it goes through the air. The Magnus effect is if you have, for example, you're spinning right and you have a wind coming 90-degree angle from the right, it will lift the round, and actually it'll lift the tip, causing lift on the round to help it. It actually counters gravity. It'll counter gravity as it's flying through the air. Coriolis effect, it impacts the flight of the bullet on a horizontal plane when shooting north to south. So I got my tomato here, and stems up on top. So if we're shooting north to south, it's going to have a horizontal effect on the flight path of the bullet as the earth is spinning, and you're firing from here. It's going to land in a different location than straight down from where it was fired. As the world turns, it moves the object in space. If you're shooting from the northern hemisphere, it's always going right. So if you're shooting from the southern hemisphere, it would then go opposite direction to the left. So that Eötvös effect, or Ötvös effect, I'm not sure, has a vertical effect on the round going east to west. It's strongest at the equator and weakest at the poles. It actually, the Eötvös effect has deflection in 2 ways. So it being strongest at the poles has to do with the centrifugal force, because the centrifugal force is stronger on the equator than it is at the north or south pole, which is at 0. So on the as the target comes spinning toward you, toward where you're shooting, the round will impact plus minus 8 inches. Oh, sorry, there's rise in 8 inches per mile. So the target rises 8 inches per mile. If we're going, this way, target's going to rise 8 inches per mile as it travels around. And then the second is due to centrifugal force, where it's basically trying to throw the round out with the spin. So it causes almost a gravitational challenge as it spins, because it's pushing that basically further out, almost trying to send it in orbit if you're going the opposite direction. If you're coming in the same direction, it's going to drop the round a little faster. It's going to push the round out, and draw it down toward the equator. That one is difficult. Both of those are a little difficult to explain. Eötvös is worst. Vertical angles. So I have my my battery box that I took my battery out of, and if we are firing downhill, the idea is that the force of gravity is in full effect from here all the way to here, and vice versa from here all the way to here. So whether you're firing uphill or downhill, that round has to fight the same amount of gravity en route to the target. So it's going to come and kind of drop in on the target here. And the same thing if you were shooting from low to high while you're shooting uphill, it's going to drop in here. Now, whether this was sitting like this, well, it would be a more flatter shot. But either way, if we're talking straight down here, 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 it doesn't matter. The point between this and this is the same, and it has the same amount of gravitational pull, no matter what the shape of that slope is in between those, the shooting position and the target. Transonic bullet performance. So as it's flying through the air, it's a supersonic. So if the shock wave is coming off the back end here and extending out, as it slows down, it moves closer to the front, and it's coming out from here. So as it hits more on the front, it has more of effect, both in that it can start to wobble as it hits the tip, and the other thing is it stays longer in that turbulent air as it passes. The rest of the round passes through that turbulence, so it can cause wobbling, depending on the stability of the round that you're using. I think it covered everything.